Okay, so this one is part two of applying a function to every column, and I'm just going to show you a kind of interesting application. Just to review, we said that if you have a matrix and you want to apply it to a column, you can use the apply operator. And for the second argument, you use a 2 to say that it should be column-wise. On the other hand, if you have lists or data frames, you can use lapply or sapply. So what we're going to be doing here is we're going to be removing low correlation variables from a set of predictors. So suppose that you have a variable called RSP, which is a response variable. So that's the variable you're trying to predict. And PRED, is a data frame of predictor variables. And suppose further that we have too many predictors, and therefore want to select the top 10 as measured by the correlation with the response variable. So we have a lot of variables, maybe 20, 30, 40 predictor variables, and we want to filter out we have too many, and we want to end up with just 10, and we're going to choose those 10 by saying which of those are most highly correlated with the predictor variable. So first of all, remember that R comes with a data set called ALGE. I'll just use head just to show part of it. ALGE. Is that right? Okay. So you can see that this is the data set, and you can see it has season as one variable, one column, size, speed, this, all the way over to here. Okay. And if you want to get a little more summarization, you can use this. See what the minimum, maximum, and so forth are for each of the variables. And we can also get a histogram of the different variables and so forth. So since we're going to end up doing a kind of regression on this, I'm going to just use the numeric variables. So you can see that not all of them were numeric, but these are all the way out to here. So I'm going to first of all just select those. So I want to select all of the rows, but just the columns 4 through 18 from ALGE, and I'm going to call that ALGE numeric. And hopefully we just have the numeric parts. So this is going to be our set of predictor variables. No, actually, I'm sorry, I'm going to reserve this one as what I'm trying to predict, and these, the remaining ones, as the predictor variable. So let me do that. So I will use, as the thing that I'm trying to predict, I'll call it the response variable, and I'm just going to use this column here. So let me do that. And then I will use the rest of them from 2 to 14 from here as the predictor, and that's going to be a data set, I believe. Now if I notice that I'm just going to show you, I forgot to do this on the other side here. So what's going to happen when I do that? It asks me to continue, so I continue that. Okay, so now I have these two variables. One is a data set. Let's see what that looks like. So it doesn't have this one, right? It starts here. Okay. And I can check what's the class of the response variable. And it's numeric. And I can check I can check the structure of the predicted, and I get this. It's a data frame like this. Okay, now let's talk about the function we're going to use here, which is correlation. So let's do help on that and see what we get. Help on correlation, COR. So we can see correlation, you can take the one vector and another vector. So y can either be null, or it can be a vector or a matrix or a data frame with compatible dimensions to x. I think that if it's null, if you don't put anything in there, then it checks the correlation of x. I'm not sure. Okay, so the first thing we're going to do is run this, the sapply. And remember that sapply can be applied to lists or data frames, because data frames are kind of a list. And PRED is a data frame. That's our list. That's our data frame of predictor variables. And then we're going to apply the correlation function. And any arguments beyond the second one, beyond the core, are passed to the correlation function. So RESP is passed to the correlation function. And every time sapply calls the correlation function, the first argument will be a column, and the second argument will be this. So it's going to be one of the columns from here and this. And with those arguments, the function call will be a column and this one, which calculates the correlation between the given column and RESP. So we're going to get, as a result, how the response variable correlates with each column or each variable in this data frame. So this is going to give us a vector of correlations, one for each column. So I run that and check it. Oops. Okay, so why did that happen? Because the data frame with all these columns, some of them have missing values, not available values, and so correlation will complain about that, and it won't give you an answer. So you have to tell correlation not to worry about that, and you do that with the following. You add in another argument here, this one. Now it doesn't complain. And if we go back to the help for that, we can see that use is a parameter that we can set, an optional character string giving a method for computing covariances in the presence of missing values. This must be an abbreviation of one of the strings everything, all obs, complete obs, NA, or complete, or pairwise complete obs. So I guess there might be a few different ones that might work. So we used pairwise complete obs. Now in my example I have only what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have only 13. So suppose I said we're going to want to choose the top 10, but suppose we want to choose the top 5, because either way, doesn't matter, but suppose we want to choose the top 5 that now you can just see them here. You can see which are the top 5 in terms of correlating with the response variable. So which are the worst ones here? I guess this is bad, and this is bad, and this is bad. But anyway, we can do this with a statement as well. And we're going to use a function called rank. And what that does is just tells you which is, it gives you the rank of every element in your vector from least to greatest. So what I mean by that is, suppose we have, let's try this statement here. Now, by the way, just to tell you, when you put a, forget about this bracket for a minute, and this bracket for a minute. So you just have this to here, to here. So you're applying that, and you're putting this in R1, right? Whatever you're doing here, you're putting into R1, right? But then we put another pair of brackets around the whole statement. And what that does is, instead of just assigning whatever you did here into R1, it prints out R1 at the end. Okay, so it's kind of like two steps in one. So if I do that, so what this is going to do anyway is, here's a vector x1, and it has 3, 1, 4, 15, 92. So what's the largest number in here? 92. What's the second largest number in here? 15. What's the third largest number in here? 4. What's the fourth largest? 3. And what's the fifth largest? 1. So this is the largest of how many? There's 5 elements. So this gets assigned 5. This gets assigned 4. This gets assigned 3. This gets assigned 2, and this gets assigned 1. So when we run it, 92 is the largest, so it's the fifth, it gets 5. This is the second largest, so it's 4. This is the third largest, so it's 3, and so on. So that's the rank function. And we're also going to use the absolute value function, which I think everyone knows what that does. Just gives you the absolute value. And but what happens if we use the function minus the absolute value? Then it gives you the negative of the absolute value. So if you take a list and give it, take the negative absolute values, then the rank is basically going to be reversed, right? From greatest to least. So if you just took rank by itself, you'd get one thing. If you take rank of the negative absolute values, you'll get the reverse order of the absolute values. Remember that for correlation, you can have negative correlations as well, but we're really interested in whether it's strong or not whether it's negative or positive. So we're going to do this. What will this do? So what is this going to do? Well, actually, I want to make it oops, sorry. I want to do this. Actually, I want to do this. So it's going to assign ranks to all of the correlations. So let's run it. And so let's see if it's right. Let's go back to here. Which one had the highest correlation? This one? Yeah, maybe this one, right? So that's that should have, of all the, how many numbers are there? I think there are 13 numbers here. So that should have the highest ranking. And what do we see? It's number 1. And how about that with the smallest ranking? I think it should be A5, which is 007. Okay? So this gives those rankings like that. Now suppose we put that into a vector. So we run this and put it into a vector test. And we can just print out tests like that. And now suppose we compare test to 6. So what will that do? Well, test is a vector with 13 elements. So it will treat 6 as a vector with 13 elements, all of them equal to 6, and it will return a vector of whether it's true or false for each one. So in other words, it will look like this. So which of the ones are true and which of them are false? In other words, when are they less than 6? So P04 was, when I lost it, but P04 was, had a ranking of less than 6, and so on. So how many are there? 1, 2, 3, 4, 5. So there are 5 with ranking less than 6. So now we'll put this vector, this logical vector of trues and false, into something called, into a variable called mask. And then finally, so this mask variable is constructed so that the top 5 correlations have corresponding true values and all the others are false. So what will this do? So we're taking the predicted, which is a data frame. We're taking all of the rows, but only the columns which are true, and the columns which are true are the ones with the highest predictor, the top 5. So we put that into a variable called best predicted. So let's try that, and let's try head of best. And so we only have the 5, the top 5. 1, 2, 3, 4, 5. Okay? And then we haven't talked about this yet, but this is how you would do a linear model for using these predictors to predict this. Well, okay, so what's wrong with that? I think it says invalid type list for this variable. So we have to do this. We want to make it into a matrix instead of a list. So as matrix, best predicted M, I called it. And then I try it with the best predicted M instead of this one. And it's okay. And it gives you the results of the regression. So this is the equation for the regression, actually. So this is the y-intercept, and this would be this times this, plus this times this, plus this times this, plus this times this, plus this times this, and that gives you an equation, and that's the regression. Well, I'm sorry, and that's that equals RESP, and that gives you an equation. That's an equation, and that's the regression equation, the linear model. And that's it.